So what is the use of Big M method? In basic matrix, if surplus variables are subtracted from left hand side of the constraints, we may not get basic feasible solution. So keeping this mind, the method known as Big M method or corner method for the solution of LPP involving artificial variable is given here. In this method, a very large negative price, say minus m, is assigned to each artificial variable in the objective function. So due to these negative prices, the objective function cannot be improved in the presence of the artificial variable. So we first remove these artificial vectors from the basic matrix. Once an artificial vector leaves the basis, we forget about it forever and never consider it as a vector to enter into the basis at any iteration. So for this clear understanding of this procedure, Big M method, once again we explain a problem. So suppose solve the following LPP by Big M method. So maximum z is equal to x1 plus 2x2 plus 3x3 minus x4 subject to the conditions. X1 plus 2x2 plus x3 is equal to 15. 2x1 plus x2 plus 5x3 is equal to 20. x1 plus 2x2 plus x3 plus x4 is equal to 10. So three conditions, three constraints are given. So observe these three conditions. There is no less than or equal to symbol and there is no greater than or equal to symbol. So, but to form a basic matrix, we have to add artificial variable to these. Examine the constraints carefully, we note that in order to get an identity matrix of 3 by 3, we need two more unit vectors, as one unit vector is already present in the constraints. Thus, we need only two artificial variables in the first two constraints. Introducing the artificial variables x5 or x6, or otherwise you can introduce in the place of xy, you can introduce s1 or artificial variables a1 and a2. We can write a1, a2 in the first two constraints and assigning a large negative price, so minus m to the artificial variables. The problem reduces to the following form. So negative prices minus m to the artificial vectors assigned to artificial variables. So then the problem becomes maximum z is equal to x1 plus 2x2 plus 3x3 minus x4. So given objective function is up to minus x4, assigning minus m to the artificial variables. So we can write like this also. So minus m artificial vector a1 and minus m artificial vector a2. The subject to the conditions. So first condition is, so x1 plus 2x2 plus 3x3 plus 0x4 artificial variable plus a1. Second artificial variable 2x1 plus x2 plus 5x3 0x4 plus a2 so which is equal to 20. Third condition x1 plus 2x2 plus x3 plus x4. So in third condition, no need to add artificial variables because after entering all this data in simplex table, we can assume that there is a unit column, unit matrix, we form a unit matrix, that is 3 by 3 unit matrix. So we require only two artificial variables, taking a1 and a2, that is x5 and x6 are two artificial variables. The simplex table is basic variable, cost of basic variables, and our first three constraint values, that is x1, x2, x. So we do again, we calculate here the simplex table. Simplex table. So basic variables, cost of basic variable, xb values. So total variables are x1, x2, x3, x4, the artificial variables a1, A2. So objective function Cj. What is our objective function? Objective function is x1 plus 2x2 plus 3x3 minus x4. Okay. So write the coefficient of objective function in Cj row. Write down. Our objective function is, tell me, maximum z is equal to x1. So x1 means coefficient of x1 is 1. Next 2x2, coefficient of x2 is 2. Next 3x3, coefficient of x3 is 3. Next x4 minus 1, artificial variable. So minus m and minus m. Next first constraint value. What is first constraint value? That is x1 1, 2x2. Next 3x3. Next x4. What is x4? In first constraint there is no x4. So 0 x4 plus a1. So a1 is 1. There is no a2. So RHS value is 15. Next second constraint. The second constraint 2x1. Next 1x2. 5x3. Next there is no x4 in second constraint. Next a1, there is no a1, 0, minus plus a1, a2. A2 is 1 a2. So coefficient of a2 is 1. So RHS value is 20. Next third constraint 1x1, 2x2, next x3 1, x4 1. So there is no a1, a2. So no need to add again a1, so a3. No need to add a3. So already we have 0 0 when we form 0 0. Third constant value is 10. So basic variables are a1, a2 and x4. a1, a2, x4. The cost of a1 is minus m, a2 is minus m, x4 cost is minus 1. This is the first table in simplex step. Okay. So now calculate Zj and delta j values. Calculate Zj delta j values. How to calculate Zj? Zj. So Zj is equal to summation Cb into Xj. So Cb column value, so minus m into x1 column value. That is minus m into 1 minus m and minus m into 2 minus 2m and minus 1 into 1. How much? So minus m minus 2m minus 1. So minus 3m minus 1. So we get minus 3m minus 1. Next value. So minus m into 2. Minus 2m. Next minus m into 1. This minus m. Next minus 1 into 2. Minus 2. How much? Minus 3m minus 2. Minus 3m minus 2. The next value. X3 column values. So minus m into 3 minus 3m minus 3m minus 5m. So minus 8m minus 1. So minus 8m minus 1. So next x4 column value. So minus m into 0 0 minus m into 0 0 and minus 1 into 1. So we get only minus 1. Next artificial variable a1 value, that is minus m into 1 minus m only. We get only minus m. Next a2 column values, so minus, we get minus. Next calculate net evaluation delta j. So delta j is equal to Cj minus Zj. Cj minus Zj. So Cj value is 1. So 1 minus, so subtract Zj from Cj. So 1 minus Zj value is minus 3m minus 1. So 1 plus 3m plus 1. So 3m plus 2. We get 3m plus 2. 2 minus 3m minus 2 means 3m plus 4. 3m plus 4. Next value 8. 3 minus of minus 8m minus 1. 3 minus of minus 8m minus 1. How much? 8m 8m plus 4. Okay. Next value 0. Minus 1 minus of plus plus 0. 0. So now select the most positive value in delta J. 8m plus 4. So incoming vector is x3. So incoming vector is x3. So now calculate outgoing vector. Calculate outgoing vector using minimum ratio. Outgoing vector is how to calculate outgoing vector. So minimum ratio, minimum of xp by entering vector is x3. So xp by x3. So xp value is 15 by 3. 15 by 3. Next 20 by 5. 20 by 5. 15 by 3, 5. 20 by 5, 4. Next 10 by 1. 10 by 1, we get only 10. Which one is minimum? 4. So outgoing vector is A2. Outgoing vector is A2. So in second table, replace x3. Incoming vector is x3. Replace x3 in the place of A2. So in second table, we get A1, x3, x4. The key element is intersection of incoming vector and outgoing vector. So 5 is our key element. 5 is our key element. So represent with a square box key element. So in second row, we got 5 as key element. So next in second table, we have to modify this key element as 1. So for this one, we have to divide key element row by key element. Key element row by key element. So 20 by in CB. So what is the CB? CB is cost of basic variable. So A1 cost is CB values. We take CB values from CJ. So A1 is cost is minus M. X3 cost is 3. X4 is minus 1. Okay. So now XP right hand side values. In second column. So modify in second column only. Second key element. What is key element row? 2215001. So this is key element row. So divide this key element row by key element. So we get here 20 by 5, that is 4. 2 by 5. Next 1 by 5. 5 by 5, 1. 0 by 5, 0. 0 by 5, 0. 1 by 5. Okay. Second row values. Next we want remaining elements in XP column and also remaining these values. Our basic variables are A1, X3, X4. So this is the XP values. So X1, X2, X3, X4, and A1, A2. So no need to calculate this A1. So A1 is in first position basic variable. So we get 1, 0, 0. X3 is in second basic variable. So we get here 0, 1, 0. X4 is third basic variable. So we get 0, 0, 1. So no need to calculate A1, X3, X4 basic variable values. So next RHS values XP. So we want a value in this position value. So we want XP column. How to calculate the remaining values in second table. So start with key element. We want XP value. So 15. We want 15 position value. So start with key element AD minus. So key element column. Key element column first value and position. So key element row, that is 20 and 3. Map 20 to 3 and 15 to 5. So AD minus BC by key element. That means 5 into 15 minus 20 into 3. 20 into 3 by key element is 5. So 5 into 15. How much? 75 minus 20 into 3, 60 by 5. So 75 minus 60, 15. 15 by 5 is 3. So we get here 3. So next step. Similarly, next we want this position value. XP column. We want number 10 position value. To start with key element again. Start with key element. And then draw a line from key element to 10. The remaining two elements are key element column value 1 and key element row, that is 20 and 1. 20 and 1. So 5 into 10 minus 20 into 1. 5 into 10 minus 20 into 1 by key element. That is that. Understood? So 50 minus 20 by 5. That means 30 by 5. 30 by 5 is how much? 6. We get 6 here. Similarly, now we want x1 column values. So x1 value is here 1. So we want number 1 position value. So start with key element. So 5 into 1 AD minus the remaining. Which numbers we want to take? 5 into 1 minus 2 into 3. The selection of these numbers is main important. 5 into 1 minus 2 into 3 by key element is 5. So we get 5 minus 6. That is minus 1 by 5. Minus 1 by 5. Next value, x1 column value, this position value. So tell me the answer. You calculate and tell me the answer. I want this position value. Start with key element AD minus 5 into 1 minus remaining elements 2 into 1. So 5 minus 2, 3 by 5. 3 by 5. The next x2 column value. X2 column value. This position value. Manohar, tell me this answer. I want x2 column first position value. Start with key element. 10 minus 10 minus. Still you are in confusion mode. 5 into 2 minus 3 into 1. 10 minus 3. That is 7 by 5. 7 by 5. Next, this position value, x2 column, third value. 5 into 2, 10 minus 1. 10 minus 1. Minus 5. Next, last A2 column values. So A2 is our outgoing vector. In first table, A2 is our outgoing vector. So no need to calculate A2. So cross out these values. So no need to calculate A2 column. Okay, once again. So first table values are here 3m plus 2. So in first table 3m plus 2. In delta j values, we got 3m plus 2, 3m plus 4, 8m plus 4 like this. So once again, I will explain this big M method. So enter all the given data in simplex table. Next, first of all, calculate ZJ values and delta J values. So select maximum value in delta J. So 8m plus 4 is our maximum value. So incoming vector is x3. Incoming vector is x3. So incoming vector column is x3. So next we have to find out the outgoing vector for this. Calculate minimum ratio, that is xb by x3. So incoming vector value. So 15 by 3 and 20 by 4 and 10 by 1. So minimum is 4. So this is our outgoing vector. So A2 is our outgoing vector. So intersection of incoming and outgoing vector is 5. So key element is 5. So divide key element row by 5 key element. So we get 4, 2 by 5, 1 by 5, 1, 0, 0. Okay. Next, remaining values we want. So in XB column, first value. So start with key element 5 into 15 AD minus BC by key element. So 5 into 15. 5 into 15 minus 20, 20 into 3. So 75 minus 16. So 15 by 5 we got 3. So like this, all the second table values. So same values. So after calculating, we got also same values. That is minus 1 by 5, 2 by 5, 3 by 5. Check once again, check these numbers with minus 1 by 5, 2 by 5, 3 by 5, and 7 by 5, 1 by 5, 9 by 5, and 1, 0, 0, 0. So it is correct. Next step, next ZJ. Repeat the process. Calculate ZJ values. ZJ delta J values. So how to calculate ZJ? That is summation CB into XJ. CB into XJ. CB column values are here. Minus M 3 minus 1. Minus M 3 minus 1. Multiply CB column first value with X1 column first value. Minus M into minus 1 by 5. Minus M into minus 1 by 5. How much? Plus M by 5. Next 3 into 2 by 5, that is 6 by 5. Next minus 1 into 3 by 5, that is minus 3 by 5. So 3 into 2 by 5, 6 by 5 minus 1 into 3 by 5. Add these three numbers. C1, X1 plus C2, X2 plus C3, X3. So we get here M by 5 plus 6 by 5 minus 3 by 5. So M plus 3 by 5. We get M plus 3 by 5. Similarly, next ZJ value in X2 column minus M into 7 by 5, that is minus M 7M minus 7M by 5, 3 into 1 by 5 plus 3 by 5 minus 9 by 5. Minus 7M 3 minus 9, that is minus 6 by 5. So we get minus 7M minus 6 by 5. Like this. Calculate remaining values. Next one, X3 column value 3. Next, X4 column value is minus 1. X4, A1 is minus A. Next, delta J. Delta J is equal to Cj minus Zj. Cj value is, Cj column values are 1, 2, 3, minus 1, minus M, minus M. So subtract Zj minus Cj. 1, 2, 3. First number is 1 minus of M plus 3 by 5. So we get 5 minus M minus 3 by 5. That is minus M plus 2 by 5. Minus M plus 2 by 5. Second value 2 minus. Second value is 2 minus of minus 7M minus 6 by 5. Is 2. So LCM is 5. So we get 10. We get 10. 10 plus 7m plus 6 by 5. That is 7m plus 16. 16 by 5. 7m plus 16 by 5. Next third value. 3 minus 3, 0. Next fourth value, here minus 1, minus 1, 0. Minus 1, minus of, plus 1. So next one, 0. So select so here fourth value is minus 1. In delta j also fourth value is minus 1. Same value. So minus 1, minus of, minus 1, minus 1 plus 1. That is 0. Fifth value, that is minus m, minus of, minus m plus m, so 0. Okay, second step. Now select the most positive value delta j, that is 7m plus 16 by 5. So incoming vector is now x2. This is our incoming vector x2. So calculate outgoing vector, that is minimum ratio, that is minimum of xb by incoming vector, that is x2. xb by x2, that is 3 by 7 by 5. xb value is 3. So 3 by 7 by 5, that is 15 by 7. Next xb value is 4. 4 by x2, 1 by 5. 4 by 1 by 5, that is 20 by 1. Next 6 by 9 by 5, that is 30 by 9. So which one is minimum? Which one is minimum? So 20 by 1 is 20, 30 by 9 means 10 by 6 some 3 point, 15 by 7 is some 2 point. Minimum is first row, that is 15 by 7 row is minimum. So outgoing vector is A1. Outgoing vector is A1. So replace incoming vector x2 in the place of A1. So in third table we get x2. Tell me third table. Tell me basic variable, cost of basic variable, xb values, x1, x2, x3, x4, and artificial variable a1, a2. So a1 also eliminated, a2 also eliminated. So no need to calculate a1 columns. So no need to cross out a1, a2 columns. In third table, in second table, a1 is outgoing vector, x2 is our incoming vector. So x2, x3, x4. In basic variables are x2, x3, x4. Cost of basic variables are 2. x2 is 2, x3, 3, x4 minus 1. What is our incoming vector in second table? So intersection of incoming and outgoing vector, that is 7 by 5. 7 by 5 is our key element. 7 by 5 is our key element. So divide key element row by key element. So total key element row, divide total key element row from xb, starting from xb to this row, total xb row, sorry, total key element row by key element. That means 3 by 7 by 5 in first row, 3 by 7 by 5, 15 by 7. Next, minus 1 by 5 by 7 by 5. So how much? Minus 1 by 5 by 7 by 5. Minus 1 by 5 by 7 by 5, how much? Get minus 1 by 7. Understood? Next, similarly, next one, 7 by 5 by 7 by 5. It is 1. 7 by 7 by 1. Next, 0 by 7 by 5, 0. X 0 by 7 by 5, 0. So we get first row values like this. So basic variables are x2, x3, x4. So x2 is in first position, so 1, 0, 0. x3 is second position, 0, 1, 0. x4 is 0, 0, 1. So no need to calculate these values. So remaining values are xb column 2 values, so x1 column 2 values. We want these 4 values. So using the formula AD minus BC by key element, we get these 4 values. Tell me 4 values. First value in xb column. So I want this position value. So how much is question value? I want XP column, second this value. How much? Starting from key element, so x4 value. So the number 4 position for this position value. Next p column, second value below key element row. Below key element row. So how to calculate this position value? Start with key element AD minus, so key element row. So it is in second position, second row. So we want this 1 by 5 and 3. 7 by 5 into 4 means 28 by 5 minus 3 by 5. By key element is 7 by 5. 28 minus 3? 25 by 5. That means 5. 5 by key element is 7 by 5. That means 25 by 7. We get 25 by 7. Understood how? This value is 25 by 7. Next, last number in XP column. So how to calculate this position value? That is 6 number value. This position value. Same process. Start with key element. Draw a line 7 by 5 to 6. The remaining two elements are key element column. So we want in third row, remaining two elements are key element row, that is 9 by 5 and key element row 3. These two values. So key we want is XP column last position value. So the remaining elements are 3 and 9 by 5. Okay. So start with the key element, that is 7 by 5 into 6 minus 3 into 9 by 5. How much? 42 by 5 minus